You know, AI can write poetry, it can create these absolutely stunning images, it can even pass the bar exam. But what happens when you ask it to solve a really complex, multi-step math problem? Well, a lot of the time, it just completely falls apart. So today, we're going to explore a breakthrough technique that teaches AI not just what the answer is, but how to actually think. We've all seen AI do some incredible things, right? But there's this fascinating blind spot. The second a problem needs a long, careful chain of reasoning, like a competitive math proof or debugging a really tricky piece of code, even the most powerful models just hit a wall. And that's the core challenge we're going to unpack right now. Researchers actually have a name for this. They call it the multi-step wall. Think about it. Large language models are amazing at matching patterns, but they really struggle when the answer isn't just one or two intuitive leaps away. It's almost like the AI takes one wrong turn in a giant maze and then just keeps running into the same wall over and over with no clue how to go back and try a different path. One tiny mistake at the beginning can just completely derail the entire solution. So, how do we normally train these models to get better at reasoning? Well, for a long time, there have been two main ways to do it. But as we're about to see, both of them have some pretty big flaws when it comes to teaching this kind of deep, step-by-step thinking. Okay, so method number one is supervised fine-tuning, or SFT for short. Basically, you show the model thousands of problems with perfect expert-written solutions, and you just tell it, hey, do this. The model learns to imitate that expert's writing, token by token. So what's the problem? Well, it gets incredibly good at mimicking, but it doesn't learn how to reason. It's like that straight-A student who can ace any test, but completely freezes up on a problem they've never seen before. The second method is a type of reinforcement learning. With this one, the model tries to solve a problem all on its own, and you only give it a reward if the final answer is correct. This is exactly like a teacher who takes a 100-page exam and just marks it pass or fail. The model gets zero feedback on where it went wrong, which makes it nearly impossible to learn on problems that need dozens of correct steps in a row to get right. So you can see we have two approaches, and they're both pretty flawed for this task. On one side, you've got supervised fine-tuning, which is just too rigid. It can't generalize. And on the other side, you have reinforcement learning, which suffers from what are called sparse rewards. Basically, if getting a correct answer is super rare, the model almost never gets a reward, so it has practically nothing to learn from. And look, this isn't just a theoretical problem. As the researchers put it right here, these limitations create a huge roadblock, especially for the smaller, more accessible open source models that are trying to learn how to tackle these really complex challenges. This is the exact gap that a new approach is trying to fill. So this critical gap is now being bridged with a new method that's, well, kind of a breakthrough. It cleverly combines the best parts of both worlds and creates a whole new way for AI to learn how to think. It's called Supervised Reinforcement Learning, or SRL, and the idea behind it is so simple, but it's totally transformative. Instead of rewarding just the final answer or forcing the model to copy an entire solution word for word, SRL focuses entirely on the process. This just completely shifts the goal of training. Now, we're teaching the model to replicate the logical actions of an expert one step at a time. The goal isn't just to get the right answer, it's to build a rock-solid foundation of good reasoning along the way. Okay, so how does this actually work in practice? The best way to think about it is like a fantastic tutor guiding a student. A good tutor doesn't just give you the final answer, right? They walk you through the problem and they confirm and reward each correct logical step you take. The SRL training loop has 4 key stages. First, you take an expert solution and you break it down into clear, logical actions. Second, you ask the model to think about what it should do next. Third, it proposes an action. And fourth, and this is the magic part, it gets a reward based on how similar its proposed action is to what the expert did at that exact same step. This introduces this really powerful idea of a dense reward signal. The model gets constant, specific feedback at every single step. And this is the game changer. It means that even if it ultimately gets the final answer wrong, it still earns rewards for the parts it did correctly. That allows it to learn and improve on problems that were previously impossible to train on. All right, so that's the theory. Sounds great, right? But does it actually work? The researchers put SRL through its paces on some seriously tough benchmarks, starting with competitive-level math problems. The results were pretty striking. Training with that standard SFT imitation method, It actually made the model worse at reasoning. The pass/fail RLVR method barely moved the needle at all. But SRL, it delivered a really substantial, clear improvement in performance. The hard numbers tell an even crazier story. SFT degraded performance by almost 13%. RLVR was basically flat. SRL alone boosted scores by 3%. But check out that last line. The best result of all came from using SRL first to teach the model the correct process, and then using RLVR to fine-tune its ability to find the single best answer. So, okay, it works for the structured world of math. But what about something messier, more complex, more open-ended, like software engineering? For the next test, they trained an AI agent to go out and autonomously fix real bugs pulled from actual GitHub repositories. Before I show you the full results, just look at this number. This represents the relative performance jump of the SRL-trained model over a strong SFT-trained model. A 74% improvement. That's huge. And here's the full picture. The standard SCFT model could fix about 4.2% of the software bugs all by itself, from start to finish. That's a decent baseline. But the SRL-trained model, it more than doubled that, successfully fixing 8.6%. This proves SRL isn't just some math trick. It's a general framework for teaching complex reasoning. So what does all of this mean? Why is a new training method like this such a big deal for the future of AI? Well, at the end of the day, SRL is kind of the missing link between those two old methods. It provides rich feedback where other techniques just give you silence. It encourages flexible thinking instead of just memorizing things. And maybe most importantly, it allows smaller, more accessible models to learn tasks that used to be only possible for these giant closed-source systems. What SRL really does is unlock a model's hidden potential. By teaching it how to systematically approach these really hard problems, we're paving the way for AI agents that are far more capable, more reliable, and just genuinely more useful than what we have today. Which leaves us with a truly fascinating question to think about. We've always focused on teaching AI the correct answer. But if we can successfully teach it the correct process, the right way to think, what's the limit on what it can learn to do next?